Okay, folks, this is Unit 8, Note 7, the last one in this unit. So if you are here, you're ready to go. Congratulations, you are almost done with this unit. And then there's only one unit to go. So we're talking about the distance formula. So before we get into that, let's look at this. A certain helicopter can fly 450 miles before it needs to refuel. Suppose somebody needs to be flown from Minneapolis to Chicago, and Chicago is going to be 225 miles east and 175 miles south of Minneapolis. Can the helicopter make the trip one way without refueling? Well, Pythagorean theorem tells us that yes, it can, because if I take 175 squared plus 225 squared, that's going to give me this hypotenuse length right here. And following Pythagorean theorem, I get 285.044, and that is well under the 450 mile mark. So the distance formula is used in a graph or a coordinate plane. And here's what you're going to do. You're going to have 2 points in the coordinate plane. x1, y1, x2, y2. Here's what you're going to do. Subtract the x's, square it. Subtract the y's, square it, add it together, take the square root. So once again, subtract x's, subtract y's, square it, add it, take the square root. So now, it might not be a bad idea to write this here. And as long as you can choose want to be y1, x, or y1, x, y2 as long as you're consistent. So for number 1, if I take 11 minus 5, that's x2, y2. This is x1, y1. So 11 minus 5 squared plus 7 minus the negative 1 squared. So that becomes 11 minus 5 is going to be 6 squared. 7 minus the negative 1 is going to be 8 squared. So this becomes 36 plus 64. So that's going to be the square root of 100, which is going to be 10. So number 2, let's say I flip it around. Let's say I call this x2, y2, this y1. So let's say I do it this way. So I can take negative 4 minus 4 squared plus 2 minus 17 squared. Perfectly legal. I can do it. I'll end up in the same spot. So negative 4 minus 4 is going to be negative 8 squared plus negative 15 squared. Now here's where you have to be careful, because if you put this into your calculator, if you put in negative 8 squared into your calculator, some calculators will give you negative 64 back, and that's just not true. So that's 64. 15 squared is going to be 225. So add those together, you get 289. So the square root of 289 is going to be 17. So those are the distances. Now, it's not always going to work out perfectly like that. All right? So let's take a look at number 3 here, which is 2, 3, negative 4, 6. So 2, 3, negative 4, 6. So if I go negative 4 minus 2, we'll square root this thing. Negative 4 minus 2 squared plus negative 4 minus 2, so I got to go 6 minus 3. So this becomes negative 6 squared, which is a positive 36. This becomes 3 squared, which is a positive 9. Square root that, so I get the square root of 45. Now, 45 is not a perfect square. But if that's the case, I got to leave it as a simplified radical. Well, I can split 45 into square root of 9 and square root of 5. Square root of 9 is 3. Hey, look, there's my simplified radical. That's all I'm doing. That's all I'm doing. So for number 4, we'll erase part of number 2 here. Give ourselves a little room to work. Number 4, if I go, let's go this way. If I go 4 minus negative 2 squared plus negative 1 minus negative 5 squared. So this becomes 6 squared. This, be very, very careful, becomes 4 squared. So that becomes 36 plus 16. This is still a square root. So that becomes square root of 52. That gets broken up into square root of 4. That square root of 4 times square root of 13. 52 can be divided by 4. So Tracy's golf ball is 20 feet short and 8 feet to the right of the cup. On her first putt, the ball lands 2 feet left and 3 feet beyond the cup. If the ball went in a straight line, how far did it go? So I like to draw a picture of what's kind of going on here. So let's say that this is the hole. Tracy's golf ball is 8 feet right. So after she hit the putt goes 2 feet left and 3 feet beyond the cup. So here it goes 3 feet this way, two feet this way. So maybe she hit it perfectly, but she hit it too hard and bounced right through the hole. So how far did it go? So we're looking for this length right here. All right, so, nope, this is going to be 2 feet. Sorry, not that one. So my 2 points become, 8, 20. My other 2 points become 2, 3. So I get 8 minus 2 squared plus 20 minus 3 squared. Square root of all that. So that becomes 6 squared. This becomes 17 squared. So 6 squared is going to be 36. 17 squared is going to be 289. So when I square root that, I get approximately 18.0278. There's my answer. So on a college campus, Kelly has her first class in Rhodes Hall and her second class in Fulton Lab. How far does she have to walk between her first and second classes? So here's Rhodes Hall. Here is Folsom Lab. So she's got to go 1/4 mile, 3/8 mile, 1/8 mile. So how far does she have to walk between her first and second classes? Well, if I cut this way, that's going to be a lot shorter. You know, I might have to walk through some stuff. But then I'm going to have to add this last 1/8 mile. So it's like I have a right triangle where my base is 1/4 of a mile. This is 3/8 of a mile. So now what might be easier here is to go with the decimal. So that's going to be 0.25. 3 divided by 8 is going to be 0.375. So I'm going to take 0.375 squared plus 0.25 squared, and that's going to equal c squared. So when I square root that, I get about 0.4507. So about 0.45 of a mile is at this length. So about 0.451 plus another eighth of a mile. So if I go 0.451 plus 1/8 of a mile, it's about 0.57 miles, that distance. So where does the distance formula come from? So basically this has got to equal 10. So if I take 7 minus a squared plus 5 minus the negative 3 squared, take the square root, figure out what a is. So here's what I would first. Before I do anything, see the big square root? I'm going to get rid of the big square root. So that is going to give me 7 minus a squared plus 8 squared, and killing 2 birds with 1 stone equals 100. So this is going to be 64. So I get 7 minus a squared equals 100 minus 64, which is going to be 36. Now wait, look. I've got something squared equals 36. Now I'm going to take the square root of it, because I've got something squared here, so I'm going to take the square root. So I get 7 minus a equals 6. But remember, I also have 7 minus a equals negative 6, because that could work too. So then I subtract 7, negative a equals negative 1. So a could equal 1. Or negative a equals negative 13, so a equals 13. That's a tough problem. A couple different ways you could have done that. I could have also gotten to here, move 36 over, and gone from there. That's a tough problem. Find the positive values of the distance between the points 3a, negative 4, 5 if the distance is 58 units. So here, same kind of idea. In fact, this is one you might want to take a minute and do yourself and see what you come up with. So if you hit pause, do it, come back, watch, and let's see how you do. I'm just going to keep going. So here's the setup. 3 minus the negative 4, a minus 5. Square both sides, because that gets rid of a lot of things that makes my life easier. So this becomes 7 squared, no square root, plus a minus 5 squared equals 58. So that's 49. So if I subtract 49 from both sides, that goes away. I get a minus 5 squared equals 9. So now if I square root a minus 3, but a minus 5 could also equal negative 3. Because 3 and negative 3 squared both equal 9. So add 5, a could equal 8. Add 5, a could also equal 2. So either one of those would be fine. Okay, that's all I got. Take a look at those, see what you come up with. Take your time with this because there's a lot of pieces to this. There's a lot of different ways to screw up. Be very strict with your order of operations.